12. If 1 unit is equal to 46.25 feet, how tall is the monument? This right here, this part right here, which I believe is also in your books, this is the scale, okay? It is an equivalent ratio type. That is the scale. It is telling you 1 unit is 46.25 feet. So, if the coordinates for the top of this Washington Monument are 1.38, comma 12, how would we find the height of this monument? Okay, so Muhammad says we need to multiply 12 by 46.25 feet. What do you think of that answer? Good answer? Not so good? What do you think? Darius, what do you think of that? Yes? No? Maybe? Not sure? Matthew, what do you think? Is that going to give us the height of the Washington Monument? Yeah. Okay, so let's go ahead and multiply that. 12 times 46.25. If you've got a calculator, let's take it to the hundredths place. Hundredths place is 2 places out, but give me the 3 numbers past that decimal point. What is it? Well, I need all of them, though. So the beginning part, too. 12 times 46.25. Actually, if you take 12 times 0.25, that's going to be 3 feet exactly, right? Yes? Am I wrong? And then 12 times 46. So what are we getting for an answer? 555 feet. Okay. Now, if you're like, well, wait a minute, if that is my scale, couldn't I set that up as an equivalent ratio? Yes, you could. So you would take 12, and that is 12 units, okay? And you could multiply that by that equivalent scale and say, if units is on top here, I want the units to be on the bottom. And 1 unit is equivalent to 46.25. So the units would cancel out and we get 555 feet. Was anybody thinking 1.38? What is that 1.38? What does that represent? The width of what? Is it the width of the building? The coordinates for the top, 1.38. So that really, that is your x coordinate. This is your y coordinate. So that's just telling you how many units over from wherever they took it. Okay, so this from here over to here, that is 1.38 units. Can you see that in red, kind of? Pretty dark, isn't it? I wonder if I should go white. Let's erase. No. Somebody's got a bag. 1.38 units. That is from the y-axis over, and then the 12 units was the height right here. Okay, because we're looking at the very tippy top. So I guess that should have been up at the top. Any questions about that? So it's 555 feet. You might want to write that down somewhere on your paper if you haven't already. And that is for the Washington Monument. Washington Monument, right? Okay. The coordinates for the top of the Eiffel Tower are 1.7 and 9.56. If 1 unit here for this, again, this is called, what do we call this? Scale. That is your scale. Okay. So if 1 unit here is 33.9 meters, how tall is the Eiffel Tower? What would I need to do there? Okay, so 9.56. Why did we choose 9.56? Because that's the y coordinate, the height. It is the height also. Okay, so this has a height of 9.56, right? Wait, where's the very top? I think it's way up here. Okay, so there's the very top. So this is 9.56. And actually that would be units. And yes, you can just multiply that by 33.9 meters. And if you want to do it as the scale, you could put the 1 unit over here. Units cancel out, and when you multiply, you get 0.084. Let's round this to the hundredths place. Which digit's in the hundredths place? Hundredth. 8. Look next door. Is it 5 or more? No, so it is going to stay the same. So 324.08. What is the units on this? Meters, right. So the Eiffel Tower is 324.08 meters. Let's see what the next slide looks like. All right, we can do this over here. The Eiffel Tower is 300, I already forgot. 24.08 meters. And the Washington Monument was what again? 555 feet? Was it feet? Can we compare feet to meters? Not very well, no. So, what do you want to do? How can I compare which one's taller? What do I have to do to one of them? I have to convert it. I either have to make the Washington Monument into meters, or I have to make the Eiffel Tower into feet. Does anybody want to be bold and take a stance? Did you get that? I see some grins. Nobody wants to take a stance. Which way do we want to go? Do we want to change them so they're both feet or so they're both meters? Feet. Thank you, Donovan. All right, so we keep this one at feet. We need to change this from meters to feet. So first of all, you start with what you have. This is what you would write down on that page 130. So 324.08 meters. All right. Oh, look at this. We happen to have a scale right up here. How convenient. 1 meter is approximately 39.37 inches. You can't even see that, can you? I got all this junk over here.
You said
39.37 inches. Okay. So I have meters. I'm going to multiply that by an equivalent scale. So 1 meter, if my meters is on top, I want to put the meter part on the bottom. 1 meter down here is 39.37 inches. 2 little apostrophes, that's the sign for inches. And if I leave it like that, that's going to leave it in terms of inches. So I want to do another conversion. How many inches make up another type of length? A foot. So there's 12 here. 12 inches make up 1 foot. So if I multiply this correctly, my meters should cancel out. My inches should cancel out, and I should be left with feet. So 324.08 times 39.37 times 1, which is the same thing, divided by 1 times 12, which is 12. And what do we get for our final answer? 1072 point, just give me the next 3 digits. 164. If I round it to the 100th place, did anybody get spit on? Look next door. Is that 5 or more? No. So it would say and be 1072 and 1600ths what? Feet. This is for the Eiffel Tower. How do you spell Eiffel? 2 F's? Mm-hmm. Yes. So which one is actually taller? The Eiffel Tower, because the Washington Monument is only 555 feet. So it is more than, not more than twice, just a little under more than twice as tall. Okay? Questions about that? So a scale is like an equivalent ratio where one thing is equal to another in a different unit. And you can multiply by that ratio of the scale. Remember, you want to try to cancel out your like units. So if it's on the numerator of the one, it should be in the denominator of the next. So you're trying to get to the unit that you are looking for. Any questions on that at all? Because you will be doing a scaling project for a room, okay? It's going to be your either college room or your dorm room, your apartment room after you leave your house, your nice house where you are. So I want to make sure everybody understands what scale is. All right, so keep working on those 3 homeworks. There are only 3 homeworks. Homeworks 1, 2, and 3. And if you have not finished the project from the last chapter, we can use the rest of this time to work on that. The rest of you, if you have the project done, you have some free time. Okay? I'm sorry for letting you down and not taking to the end of the class period. I feel I am letting you down on the educational opportunities of this class. All right. Perhaps I could get some more grading done. All right. Donovan, I would like to have a word with you. Does anybody have any questions about their project? Yes. Do you have any passes on?
I don't think I ever got that.
Didn't we go through this one other time? Did I just write you a single one? Oh, okay.
Fix mine up.
Yes.
Never submit it.
Yes. All right. So I'm gonna get you your pass. Date. Can you believe November? I feel like November has just flown.
October kind of did too.
Well, yeah, we had a 1 week break. student, oh my gosh.
Amir Khan.
Hmm?
Amir.
Oh, yeah. I would have gotten it. I'm telling you, that lack of sleep. Coleman, right?
Yeah.
Sorry.
Thank
Okay. All right, Mr. Donovan. So I graded your project. It was really quite good. But I haven't seen you do anything in here on it. I mean, did you do that project yourself?
Not by myself.
Huh?
I help.
Okay, who was helping you?
But I really got help from somebody out of class. My sister, that's in college.
Your sister?
That's in college.
Oh, what is she doing in college? What is she taking? Is she like older?
Stuff.
Really?
No, I'm
Oh,
not doing it.
okay. All right. Well, I appreciate that. I'm glad to know that. So I will add this up. Was it when you finally understood what you needed to do, what did you think? It was hard, it wasn't too bad, it was
It seemed like it's more about statistics to me. Like it seemed like it's more about statistics than regular math.
well, I mean, it was in the chapter called Data and Statistics, so yeah, that definitely was what it was. Okay, all right, well, thank you. And let's see here.
What's the R
Yes?
value?
Huh?
What's the R value?
Okay, the R value is the strength of the correlation between your two attributes. So if it's the R value, the R value itself can go from -1 to +1. So if it's -1 or 1, then it's very strong. If it's close to 0,
How do
it's
we find
very
that?
weak. You can actually find it. You can actually find the R squared value. So by squaring it, instead of taking it from -1 to 1, you take it from 0 to 1. So if you go to the little histogram picture on the far right of one of your, now you have to go back to CODAP though.
Okay. It's in here somewhere. I think so, it is.
You probably can't see. Move it so you can see.